Good evening, everybody. So welcome to this lesson. So we will be doing a couple of multiple choice problems, which I shared with you guys to try. Now, problem 14 on that list was consider two positive integers a and b, which are such that a to the power a times b to the power b is divisible by 2000. So this guy must be a multiple of 2000. Now, what is the least possible value of a and b? So the trick to solving this question is to factorize 2000, to prime factorize 2000. So it is, you have three zeros, so you get three tens. Each 10 becomes a 2 and a 5. So 2000 is 2 times 1000, which is 2 to the 4 times 5 to the 3. Can I get a smiley face that if you get this problem in an Olympiad contest, it makes sense to prime factorize 2000? So you see you only have 4 copies of 2 and 3 copies of 5. Can I get smiley faces just to show that you guys are here and that you guys agree? If you disagree with a calculation, please let me know in the chat. Alright? Now, I think a lot of people were caught out by this problem because obviously you can't make A2 and B5. So no, they maybe try things like maybe making B10 and A2 and things like that. But if you run through the possibilities and you want to minimize the product, it turns out that the best is to make either A1 or B1 and the other one 10. Because then you get 1 to the power 1 times 10 to the power 10, and 10 to the power 10 is clearly a multiple of 2000. So the smallest possible value for AB, remember A is a positive integer and B is a positive integer, turns out that the smallest possible product is 10. Are there any questions? If there's a question, unmute. If you tried this problem and you got stumped, maybe you can tell me why this problem stumped you. But yeah, the correct answer to this was B. Alright, silence gonna mean that you guys are happy. Let's have a look at problem 5. So in problem 5, A, B, and C are three positive real numbers. So one way you can say this is A is an element of the set of real numbers and A is bigger than 0. Likewise for B and C. Alright. Now we are told that this guy is equal to 0. And then we need to figure out, what does the triangle look like? Is it maybe a right angle triangle? Is it isosceles? Is it scalene, equilateral, or none of these? Alright, so we need to think on how to solve this question. Now, can anybody propose an idea that they've tried that worked for them? So not the answer, just an idea. If you can unmute and speak your answer, that would be great as well. Any ideas? Zarwik, Takura, Richard?
So we could possibly, if we assume it's a right angle triangle, then we can try the Pythagorean identity and see where that leads us.
All right, but
So we want to study cases.
all right. So you want to reverse engineer, all right?
Yes.
But clearly this is what's given. Doesn't it make more sense to start with a given bit of information and to mold it, to manipulate it? Yeah?
Sounds a lot difficult.
All right, well, let's think a little bit of it, all right? So what we have is the following. We have a squared, and then we have minus 4ab. What would be a good thing to possibly put there as a plus? Any takers? Think of factorization.
Just the, no, don't worry. I'm going to stay silent for a bit. Yeah, 2b squared.
Okay, I'm hearing b squared, I'm hearing 2b squared, but I'm looking for something else.
4b squared. I'm sorry. I mean 2b parentheses then squared.
Can I get smiley faces in the chat that this is a good choice because this now becomes a minus 2b squared. Alright, thank you, Luke. Can I get smiley faces that you guys see that maybe it's useful? Thank you. Can I get 3 more smiley faces? Thank you, Richard. 2 more smiley faces. All right, maybe this is pretty useful. All right, can I get more smiley faces? All right, Edward, Jared, Kihan, can I get more smiley faces that you guys are happy with this plan? All right, can I get one more smiley face that you guys are happy with this plan? All right, all right. Now, if I do this, if I steal 4b squared, what else do I have to put here to do the accounting? 5b squared splits as 4b squared plus?
B square.
Obviously. Alright, so let's just do, we have the a squared that's done. The 5b squared we split up. The minus 4ab we got there. And so then this becomes minus 4bc and that becomes plus 4c squared. Alright, now can I rewrite the last three terms? Anybody?
Indeed so.
How?
B minus 2c and then the whole thing squared.
Good stuff. Alright, do you now see? We know that this is equal to 0. So we know that this is equal to 0. And so what can we deduce now?
We can get a ratio for A, B, and C.
I want more than that.
We can have that both the insides of the brackets must or both be larger than 0. Oh no, don't worry, I'm stupid. Give me a second to think.
Okay, go. This is what, when you play chess, you got to think. When you play any board game, you got to think. So here, what can we deduce? If you can switch on your microphone, you're welcome. If you don't have a microphone, you can type it in the chat. What can we deduce now?
Well, A would have to equal 2B and B would have to equal 2C.
Good stuff. Can I get smiley faces that you guys agree with this? A real number squared plus a real number squared is 0. So that means each bracket is 0. And so therefore A must be 2B and B must be 2C. Alright, can I get one more smiley face? Thank you. Alright, and so now let's do some mathematics. So we have a triangle. And the one side is C. The one side is B, which is now 2C. And what is A in terms of C? Who can tell me what A is in terms of C? Well done, Luke. Gold star to Luke for getting it first, according to my screen. Yes, because A is twice B and B is 2C, so we see that A is 4C. Alright, but now let's look at the following fun calculation. B plus C, we just worked out B is 2C, and so B plus C is 2C plus C, which is 3C, and 3C is less than 4C. So we get that B plus C is less than A. Who can tell me now what is the answer to this multiple choice question?
Does not exist.
Good stuff, because you know in a triangle, if you add up two sides, it's got to be bigger. So we end up here with a contradiction. And so the answer to this multiple choice question is E. Well done to Kura for saying it in the chat as well. Alright, are there any comments?
Dr. Wiggins?
Yeah?
For this, what I actually ended up doing is instead of setting them equal, I just ended up doing ratios for A to B to C. And then using the ratios, I did the same thing with the inequality.
Well, as I said, I'm just showing you one solution. If you got it in a different way, that is also fine. Alright, so the way that I'm showing to solve the problem is not the only way. Sometimes it could be, not the best way to solve the problem. Alright, so if you have another way to solve it, show it to your teacher. If you have a maths buddy in class, show it to your maths buddy in class. So not only do I want you guys to be able to solve problems, but able to communicate it and to convince somebody else. Alright, so yes. Alright, so there were some really nice problems in this paper. Alright, did anybody thought that this was an evil problem? Any comments?
I don't believe math is intrinsically evil.
Good.
It's intrinsically feeble-minded.
I love the way you think. I love the way you think. All right. So yeah. So here, fiddling, you can show that if A, B, and C are three positive real numbers that satisfies that, then it's impossible for them to be the sides of a triangle. All right. Now, I think problem 15 is the toughest problem in the paper. All right. Is there anybody that think they got this answer? So this is a nice geometry problem, and angle chasing is not enough. You need to do something extra. So we need to pull out a little bit of magic. So are there any takers that think they've solved this problem? Oh, oh, okay. So you somehow got an answer. Do you mind sharing what answer you got? All right. Now, this problem, you will see in a moment, if you're right, this problem can be solved in many ways. All right. This problem can be solved in many, many ways. You can use trigonometry, but I'm going to, my first name is Harry, so thinking of Harry Potter. So I'm going to employ a little bit of magic. So I'm going to do a little bit of a magic trick. And so the magic trick is I'm going to add a very special construction. So to finish this problem, I'm going to do a construction. All right. So what I'm going to do is the following. So from point B, I am going to drop a perpendicular to the line AC. So L is on that line. So I'm going to draw BL perpendicular to AC. Alrighty, so bearing with me, we have this. Alright, so just for fun, who can tell me what is angle DAC? So angle DAC, what is the value of angle DAC? You can chat it or you can speak it. Anybody? This angle over here, this dot, what is the size of this angle? Yes, Takura, it's 15. Can I get somebody to unmute and say they agree? Because that angle plus that angle should be 45 degrees. Thank you, Luke, for agreeing. All right. So now we drop a perpendicular, and then the next thing that we're going to do is we are going to join L to D. So we're going to join L to D. All right. So this problem can be solved in many ways, but this is the solution that I came up with after struggling with a problem for 10 minutes. This is the solution I came up with. Maybe there's other ways of solving this question. All right, so let's look at sine 30 degrees. We know sine 30 degrees is a half. And what's the definition for sine? Who can tell me what is the definition for sine? If you're grade 11 or 12, you should know this. Guys, please let me know in the chat. Do you guys agree with Luke? Yep. So let's just going to use O over H. So if you look at triangle BLC, the opposite is BL and the hypotenuse is BC. All right, which is equal to a half. Now, if you look at this carefully, BC can be written as the following. BC can be written as twice BD. Can I get a smiley face that you guys see that sine 30 is opposite over hypotenuse and BL is the opposite? The hypotenuse is BC, which is twice BD. Can I get smiley faces if you agree? If you disagree, please ask a question. I have 2 smiley faces. Can I get one more smiley face? All right, so yeah. And so if a half is equal to this, it implies what? Who can tell me what does it imply? Just staring at this equation, just staring at this part of the calculation, what do we end up getting? So if that fraction is equal to that fraction, yes, Richard, we get that BL is equal to BD. So this is kind of good news. So we know that BL is equal to BD. All right. And so what does this entail? What does this entail about triangle BLD? Yes, it's isosceles. So that triangle is isosceles. All right. But now let's think a little bit more. All right. This angle is 30 degrees. So what is the size of this angle? So angle LBC is equal to, who can tell me what is the size of angle LBC? You remember BL is perpendicular to AC. Takura, that's a little bit too much. Takura, that's a little bit too much. So this angle plus this angle plus this angle must add up to 180. So yes, Richard, this angle is 60 degrees. All right, so this angle is 60 degrees because 90 plus 30 plus something must add up to 180. Can I get smiley faces that you guys are with me? Can I get smiley faces? I want 2 more smiley faces, 1 more smiley face. Yes. All right, so this is 60 degrees. BL is equal to BD. So actually we have the following. The triangle BLD is equilateral, i.e. that BL is equal to LD is equal to BD, which is equal to DC. All right, so look how cool this is. All right, and so now we are going to do a little bit more mathematics. All right, so we now know that with this clever construction, that triangle BLD is an equilateral triangle. All right, so BL is LD is BD is equal to DC. All right, so there's a lot of cool things that we get here. All right, so typically when you do Olympiad questions, maybe draw it big so that you get something from it. Alrighty, now let's do a little bit more thinking here. Alright, so what else can we deduce? Alright, so what else can we deduce? Are there any observations out there that somebody wants to make? Are there any observations that somebody wants to share that I haven't mentioned yet?
So if we look at triangle A, I'm quickly going to ask, do we have like at angle DAC? Is that 15 degrees? I'm guessing.
DAC is 15 degrees. Yes.
Okay, so then we have that angle ADC must equal to 135 degrees.
Correct.
And that is the outside angle of triangle ABD. So we can deduce angle BAD from that, which we could possibly use, I'm assuming.
All right. Okay. So obviously this is an isosceles triangle, an equilateral triangle. So you agree that this is 15 degrees.
Yes.
All right, because in that triangle, each of the angles have to be 60 degrees. Yes. And from this, what can we deduce now? So yes, Chatterjee, LD is BD and BD is DC. So that is quite correct. So LD is BD and BD is BL, which is DC. So Chatterjee, your observation is correct. But can anybody tell me in the chat what extra isosceles triangle is lurking here? So triangle, what is isosceles? Yes, ALD. ALD is isosceles. So IE, we have the following. that AL is equal to LD, which is equal to BL, which is equal to BD, which is equal to DC. Can I get smiley faces that you guys agree with Luke? So ALD is isosceles, so AL is LD. So now we have that AL is LD, which is BL, which is BD, which is DC. Alright? And now, if we take a circle with center L, with radius LD, it passes through which points? So, circle, center L, with radius LB, passes through which points? Who can tell me? So if you take a ruler and compass, L is the center of the circle and the radius is LB, it passes through which points guaranteed? Any takers? What's the opposite of good? Yes, it passes through B, A, and D. Because the distance from L to A is the same, the distance from L to B is the same as the distance from L to D is the same. Alright? So another way of saying this is L is the circumcenter of triangle BAD. So L is the circumcircle of triangle BAD. Can I get smiley faces that you guys agree with this? If you have a question, say it in the chat or unmute. Alright? And so we actually now have discovered quite a lot about this diagram. So we discovered lots about this diagram, and so now we are actually in a good position to be able to solve this question. Alright? So remind you, what is our goal? Our goal is to find angle BAD. So our goal is to find this angle lurking over here. So we want to find this angle over here. Alright? Can anybody give me an idea of how would they go about finding this angle now? So what theorem, what result do you think would be useful to find that angle sitting over there? Alright, so we explored, we had some adventures. So Takura saying cyclic quads. Alright, so I need a little bit more. How would we go about finding this angle over here? So I hope you go home later tonight, redo this question, alright, and write it up as a nice little essay. Alright, so we know that that's 90 degrees, so we also know that that's 90 degrees. So I need a plan. Alright, can somebody give me a plan on how would they tackle this question? So you got to be careful here. We have an equilateral triangle. We have an isosceles triangle. Alright, so we got to be very careful here. Yeah, the angle at the center is equal to that. But, ladies and gentlemen, remember that AL is LB. Alright, so what kind of triangle? I'm running out of space here. So triangle ABL. So triangle ABL is a what kind of triangle? Who can tell me what is triangle ABL? Triangle ABL. I'm looking for the correct adjectives. If you don't know what adjectives are, quickly Google it. Yes, Chatterjee, you are spot on. Do you guys see? One angle is 90. The two sides are equal. So ABL is an isosceles triangle. Takura, do you see there's no need for cyclic quadrilaterals here, Takura? Takura, can I get a smiley face that there's no need for, yep. And so that's 90 degrees, so this has got to be 45 degrees. So the angle that we're looking for, so the answer is going to be 45 minus 15 degrees, which is 30 degrees. Hashtag some Potter magic. Alright, there are other ways to solve this question. Alright, but this is a good solution using some geometric ideas. So we just needed to know sine 30 is a half. We just needed to make a couple of extra point, which is point L, where BL is perpendicular to AC and L is on AC. And then we just needed to play with equilateral triangles, isosceles triangles, and knowing that ALB is therefore an isosceles right angle triangle. Chatterjee, can I get a smiley face? You can also add isosceles right angle triangle. Yes. All right. Are there any questions? So you can see why this was problem 15. Somebody, so you said 30 degrees, you were spot on. 30 degrees is quite correct. All right. So maybe you got it in an easier way. All right. Guys, is this beautiful? Yes, no? This is a really tough geometry problem. You can tease your teacher tomorrow at school with this. All right? You can see we don't need anything more crazy than a little bit of geometry, knowing equilateral triangles, isosceles triangles, and a right-angled isosceles triangle. All right. All right. Any questions? Anybody? So guys, get your hands on Olympiad problems. Have those adventures, all right? If you're not reading a book, you're missing out on a cool story. If you're not doing math problems, you are missing out on adventures. You are missing out on cool problems that you can solve and share with your family members, your teachers, or friends at school. So yeah, I do think this was the toughest problem on this puzzle. Alrighty. Can I get a smiley face? Are you guys ready for another problem? Can I get a smiley face that you guys are ready for a problem? So you can see Olympiad problems are really testing your creativity and taking the tools at school. Can I get one more smiley face? There are some people here that is very quiet. Jared, Kihan, Luke, Robert, Sharik, Maharaj, Waikwacha. Guys, you are welcome to give me smiley faces, Edward, in the chat. Alrighty. So the next problem that I want us to look at is this guy, which is number 13. So we want to know what is the condition on the constant A such that this equation equal to 0 has 4 distinct real solutions. Alright. Now you can see that this is a polynomial of degree 4. So we want this polynomial of degree 4 to have 4 distinct real solutions. Who can give me a polynomial of degree 4 with no real solutions? So for fun, your teacher should have asked you this, but if they haven't, I'm asking you now. Who can give me a polynomial of degree 4 with no real solutions?
X to the 4th plus 100.
Correct. Yeah, and put it equal to 0. Alright? So x to the power 4 plus 100 equal to 0 is a polynomial with degree 4 with no real solutions. Alright, so now let's get back to the problem. So like the previous problem, we can try to manipulate it. So looking at this, it kind of makes sense to have x to the 4 minus 2a squared, 2ax squared plus a squared together, because then this becomes x squared Apologies about that. That's meant to be a minus over there. Minus a squared, and the rest is x minus a. But do you see that there is here no common factor? Can I get a smiley face that you guys see? If we rearrange it like this, we get something squared plus x minus a, but we can't factorize the bracket, alright? So we are stuck, alright? There's no point in crying, alright? You gotta move onwards and upwards, alright? So we tried that and we got stuck. So what do we do in science? We try something new. We got to try something new. So you guys had 2 weeks to look at this problem and give it a go. Are there any ideas that you guys tried that you thought is worthy to mention tonight? Any takers? Daniel, Edward, Jared, Kian, Zerwick? You can give me a sad face if you are really stuck or have no idea. Alright, so yeah, you know how people get challenged when they do the comrades or trying to climb Mount Kilimanjaro or doing an unseen problem. Alright, so yeah, alright, so we got to make a plan over here. Alright, so what do we like? Do we prefer polynomials of degree 4 or polynomials of degree 2? So let me know in the chat. Degree 4 or degree 2? Yes, obviously we prefer degree 2. Alright, so what we have to do is something new. Alright, so like in pottery, you mold something. So let's try to mold something in this manner. So a squared is good, which is that guy, and then this guy and this guy has got an a over there. So then I can say the following. I can say minus a 1 plus 2x squared, and what remains is the following. X to the power 4 plus x is equal to 0. Alright, so you can see that, maybe if that is 3 and that is 4, so you end up getting, I'm just going to make it 5 for fun. You see? Yeah, alright. So this now becomes a quadratic in A. This is the clever plan over here. Alright, and how do we solve a quadratic equation? How do we solve a quadratic equation? Give me some ideas. Yeah, so a quadratic formula is the one I would probably go for, but if you don't want to use a quadratic formula, there are other ideas you can try. So thank you, Tacha D and Takura. But what else can you try? Yes, factorization. All right, but just look here. When you apply the quadratic formula, you get minus b plus minus the square root of b squared minus 4ac. So 25 minus 16 over 2. So this becomes 5 plus minus 25 minus 16 is 9. So it becomes that. And so you can see that the roots are 8 over 2, which is 4, and you get 1. And so because the roots are that, it factorizes as a minus 1 times a minus 4. Alright, so let's do the following now. So let's use the quadratic formula now. So let's use the quadratic formula. So we see that a is equal to minus b, which is this, plus minus the square root of the coefficient of a. I'm just going to take it slow because some teachers like to see a lot of calculations. B squared minus 4a squared over 2a. Can I get a smiley face that you guys see? The coefficient of a squared is 1. The coefficient of a is minus 1 plus 2x squared in brackets, and the constant is x to the 4 plus x. So this is pretty clever. So we decided that we are rather going to look at this quadratic. And now let's see what we get. We get 1 plus 2x squared plus minus. So if we do all of this, we get 1 plus 4x squared plus 4x to the power 4 minus 4x squared minus 4x to the 4 minus 4x. So that kills that. And so now this becomes 1 plus 2x squared plus minus the square root of 4x squared minus 4x plus 1. Are we jumping for joy? Yes or no? Does this look promising? Yes or no? All right. Takura, why are we happy? Who can tell me why are we happy here? I mean, if I see a square root sign, I would like it to disappear. Takura, I need a little bit more. I need a little bit more. You are hot on the trail, but I need a little bit more. Look, why can we remove the root? Give me a mathematical fact. Give me an identity. Can anybody give me an identity that's going to be useful here? All right, you guys are hot on the trail. All right, so who can tell me what is special about this? This is not just any. So who can factorize this for me? This is not just any quadratic. This quadratic is, yes, it's a perfect square. So can anybody complete this for me? Thank you, Luke. This is what I'm after. So note that this is true. Note that this is true. Can I get a smiley face that you guys see that this observation is crucial? All right. So when you drive, you got to be wide awake. When you do maths, you got to be wide awake. So we get plus minus. Brackets are your friends, so you protect it with brackets. So if you do that, you get the plus option would be that plus that. So the ones disappear. So you get 2x squared plus 2x over 2. So that ends up being x squared plus x. Or if you subtract, then the double minus becomes 2, but 2 divided by that becomes a 1. And that becomes plus x squared minus x. So if you use the plus option, you get the first guy. If you use the minus option, you get the second guy. All right? Can I get a yes in the chat that you guys agree with this? Can I get 2 more yeses that you guys agree with this? One more yes. Daniil, anybody that's still here that haven't given me a yes? Thank you, Kian. Thank you, Zerwe. All right. So this means that crocodile actually factorizes as the following. It factorizes as x squared plus x minus, sorry, you typically go a minus the one root, a minus the other root. And we know we want it to be 0. All right. So this is not a factorization that you would have discovered easily, especially if you use the original form. But if you decided to view it as a quadratic in A, not in X, you can see that it factorizes as follows. If you are bored tonight and you're struggling to go to sleep, multiply out those 2 brackets and see if it's indeed correct. So please, if you can't sleep tonight, do this calculation. All right, so we are getting somewhere. All right, so I'm going to need new space. So let me just insert a new page. So what we have is the following. We either now have x squared plus x minus a is equal to 0, or we have that x squared minus x plus 1 minus a is equal to 0. And so we want 4 real roots. So we want here 2 distinct real roots. And here we also want 2 distinct real roots. Alright, so how do we ensure that a quadratic has 2 distinct real roots? Now a little bit of theory that you should know. How do we verify? Yes, Chachaji. So we want the discriminant to be positive. Can anybody unmute and say they know this from school? Their teacher has taught them this. So a gold star to Chachaji for getting it first. Thank you, Takura. I'm glad to hear that the grade 10s are also learning this. Alright, so we want the discriminant to be positive. So here, the discriminant is going to be the coefficient of x, which is 1 squared minus 4 minus a. So this becomes 1 plus 4a, which must be positive. Alright, I hope I haven't destroyed this. And so this means that a is bigger than what number? Who can do the maths? So for the first guy, if the roots are real and different, that means the discriminant must be positive. So b squared minus 4ac must be positive. So that means 1 plus 4a is positive. So a must be bigger than what number? Yeah, quite right. Minus a quarter. So this is coming from there. And so also looking here. So looking here, we want the discriminant also to be positive. So the coefficient of x is minus 1. So minus 1 squared minus 4 times the coefficient of x squared is 1. And that's 1 minus a. That must be positive. So we have 1 minus 4 plus 4a must be positive. So we see that 4a has got to be bigger than 3. So we see a has got to be bigger than 3 quarters. Alright, so if we want a to be bigger than minus 1 over 4 and a is bigger than 3 over 4, we want that what must be true? So if you want this to be true and you want this to be true, that means that a must be bigger than what value? A little bit of logic. What goes there? Yeah? Do you guys agree with Chatterjee? Can I get smiley faces that you guys agree with Chatterjee? Alright? So you want 2 wishes. You want a to be bigger than minus a quarter and a bigger than 3 quarters. So you pick the biggest number. So you can summarize this. So your final answer would be that a has got to be bigger than 3 quarters. And so now you can see that if a is bigger than 3 quarters, the first quadratic has 2 different roots. This quadratic has 2 different roots. And so therefore you're going to end up with 4 different roots. So the answer to this question is D. Alright, so here we employed a different trick to help us to manipulate the expression. So instead of looking at a polynomial of degree 4, we decided to look at a polynomial of degree 2 by rewriting things as a squared, 1 at the front, a with something in terms of x at the front, and the constant is something in terms of x. So we get to use the quadratic formula, and that allowed us to understand this polynomial a little bit more, which allowed us to solve this problem, and we get that the answer to problem 13 is D. Alrighty, so this is the end for the session. So guys, here are the rest of the answers if you've tried it, and I want to leave you with a very important message. The only way to learn mathematics is to do mathematics. Alright, this is a quote by Paul Halmos. So please guys, do try the other problems and see that you agree with the answers that I'm sharing with you. So I hope you enjoyed this